Welcome everyone. Thank you for making your way across the road to come and talk about some cool JavaScript stuff. So I guess just to introduce myself quickly, my name's Richard. I'm a senior GIS developer, as Ben said. I also work in our technical research team at Esri UK. The combination of these two things means that I spend quite a lot of my time using JavaScript and also have quite a heavy focus on the latest features and emerging technologies that we see in the ArcGIS system. So between those two things, hopefully this is going to be a nice, entertaining session. I thought I was being really creative by having this rainy scene of Edinburgh. It turns out the GIS community is full of creative people, so lots of people have done this morning. But hopefully through this we'll uncover why using these kind of things in our developer tools can give you a little bit more creativity. So I wanted to start by just saying that I know that we get a big variety of different people in these sessions, and so whilst it is about the JavaScript API, I know that there's people who will probably be using JavaScript every day. There'll be people who are interested in taking their first steps, and there might be people who are just curious but not really ready to take their first steps. So we're going to try and make it applicable to everybody, and you'll see why in just a few minutes. So just to say that everybody's very welcome. You don't need to be a hardcore developer. We'll start off with a session overview so you know what to expect. Because we have two developer sessions running back to back now, we're going to start off by just having a quick look at ArcGIS developers as a whole, and that's going to help us put JavaScript into context. We'll have a look at what it is and why everybody should care, not just developers. We'll then move on to the star of the show, the ArcGIS API for JavaScript. We're going to be focusing on what's new. I'm going to show you some specific examples of functionality. But at the same time, I want to give you some kind of broader themes that we see coming down the pipeline when it comes to JavaScript. So hopefully you get that kind of broader context rather than just specific examples. And then we'll finish off by giving you some resources that you can use to stay up to date kind of between these sessions when we all meet up together. And that's the plan for the session. So let's start off by introducing you to ArcGIS developers. So, in a nutshell, ArcGIS Developers is our solution for embedding geospatial capabilities into your apps and systems. So everything from if you're writing, let's say, an Android or iPhone app, all the way to embedding geospatial capabilities into a back-end system that nobody ever really explicitly sees, but they get tremendous benefit from, and anything in between those, we have tools to help you out in ArcGIS Developers. Now, I like to put up a slide now just to give you a sense of the variety of things that we can build with our developer tools. In all honesty, this is a collection of things that I thought were really pretty and cool, but they do have a purpose as well. So to give you an idea of the variety, up on the top left-hand side here, we have a globe which has exaggerated elevation, and this gives us a really creative way of seeing mountain ranges and trenches in the ocean in a really creative way. In the middle, we have one of our game engine SDKs where we're bringing GIS content into a game engine to give us really good control over things like lighting and physics in that environment. We have data coming from the moon, and we have a whole host of different cartographic techniques that we have access to in developer tools. So hopefully this gives you an idea of all the different possibilities that we have when we start using ArcGIS developers. And you might be thinking, well, this is great, but maybe I'm not that familiar with developer tools, so this seems a little bit out of reach for me. Well, that's where I want to introduce you to another idea to keep in mind as we go through this, and that is that ArcGIS itself is primarily built with these exact same developer tools that we give to you. What does that mean? Well, first of all, hopefully it means we take it very seriously, and we build these tools with the capabilities that we need to build all of the amazing off-the-shelf products that we have. What it also means is that the features that you see coming in our developer tools typically make their way into our off-the-shelf tools pretty soon after. So even if you're not a developer, you can have a look at this session and it will give you an idea of some of the things that will start coming into our off-the-shelf tools. Particularly with JavaScript, things like the map viewer and the scene viewer in ArcGIS Online, dashboards, and a whole host of other tools are built with the JavaScript API. Okay, Great, where do we start? Well, we're going to start off by heading over to our developers website. As I say, I'm going to give you a brief overview of that, and then we'll jump into some JavaScript examples specifically. Our developers website has been, well, since the last time we were in this room a few years ago, has been completely overhauled, and it's always being updated to be more applicable and more useful to all different experience levels. So I'll let you have a look through this in your own time, but there's all sorts of developer guides aimed at all different audiences that you can have a look through. It gives you an overview of the key functionality and everything like that. So as I say, you can head over to the developers website and have a look at that a little bit later on. But one page that I like to visit personally is the documentation page. And on this page, we get an overview of all of the different tools that we have available to our developers. So there's all sorts here. There are tools for extending core ArcGIS products, such as the ArcGIS Pro SDK. There are app builders. So if you're just taking your first step into development, you can use these tools to configure a custom experience without having to write any code, or just writing a little bit of custom code to supplement a largely configured experience. We have a calcite design system. If you want to adhere to Esri's look and feel in your apps, that will give you some really nice tools to do that. We have scripting services like Python and the REST API for doing automation. We have game engine SDKs, which Mark and Rachel will talk about a little bit later on, touch on, as with the runtime SDKs for building native apps. And then finally, we have web APIs, and this is where JavaScript lives. So web APIs are a really great option if you need to work in a kind of connected environment using primarily a web browser. And whilst traditionally they may have been not quite as powerful as runtime SDKs, where you can access that core device hardware, nowadays web APIs are getting incredibly powerful, and you'd be surprised the number of things that you can do with them. So we have our JavaScript API. You'll notice that we also have a few other options down here, which are open source mapping libraries that are written in JavaScript, such as Leaflet and OpenLayers. In a completely non-biased way, I would say that the ArcGIS API for JavaScript is probably the most fully featured of these. So if you're wanting to do complex GIS workflows in your JavaScript apps, I would be looking to that API first. If you have skills in the likes of Leaflet or OpenLayers and you want something that's just lightweight and simple, then by all means have a look at those as well. They'll let you use your ArcGIS data directly in those APIs. They're fully documented and fully supported if you have a developer subscription. Excuse me, so that's an overview of our tools. Now let's start talking about JavaScript itself. In terms of, if you're interested in like the detailed functionality of what's new, you can always head to the release notes, and that has a historic archive of all the different releases that you can dig into the details of it. But for today, what we want to have a look at is just some examples. Most of what I will show you today, you'll find under the sample code section. So if you do want to go and have a play in your own time, there is a latest samples category, and you can have a dig through these as well. And what these samples let you do is, sorry, I can't navigate and talk at the same time. Always been a weakness of mine. So they'll show you the live sample, and they'll also give you a description of how they're actually built, including some code. You can jump into the code and make some edits in a really interactive way. So this one is, incidentally, a new feature of binning, where we can bring in a whole load of data into our map, and then on the client side, bin that into these kind of discrete polygons to display the data in a much more performant way. So that's one example. So the first category of new features I wanted to talk about is performance. Performance sometimes sits in the background quietly, making all of our lives much better without really shouting about it. But what you will tend to find in each of our release notes is an example of a part of the API that has been significantly improved in terms of performance in this release. Our latest release, one of the examples of this was heat maps. So on the left-hand side, we have one version prior to our latest one. On the right-hand side, we have the latest version. You'll see that there's a tremendous increase in the time it takes to render these heat maps. This happens a lot in our API. Sometimes it's based on underlying web technologies getting better, which it was in this case. Sometimes it's just kind of GIS techniques improving as well. But it's always interesting to see how far we've come if you go back a couple of versions and have a look at these performance increases. But as well as making our apps more pleasant to use, performance actually has a really big impact on usability. And also, when you increase the performance in the right areas, it will enable you to do whole new workflows that you couldn't really do before just because you were constrained by the amount of time it took to either navigate a map or load the data into it. So one example of that is, to show you the kind of volume of data we can bring into our apps nowadays, is this dot density map. So this is a cartographic technique where we display a single point per a number of objects or people in this case. So at this zoom scale, we have 1 dot per 400 people, but as we zoom in, that starts to decrease. Now it's 1 dot per 50 people, and eventually you'll get 1 dot per person. And given the geographic area this is covering, hopefully you can appreciate just how much data is streaming into this app, and yet it remains completely performant. So this is the case with different cartographic techniques, but also if you just grab a really big feature layer nowadays and bring it into your JavaScript app, hopefully you'll be pleasantly surprised by the performance that you get out of it, while still having full access to all the attribution of that data and so forth. So as well as kind of vector-based data, we're also always improving the performance of things like raster data as well. In this example, we are looking at the flow renderer. So this is a way of visualizing raster data. It's typically used for meteorological data that has time attribution in it as well. And in this case, we're looking at the sea surface temperature around the world. We're using this really cool Arctic projection to view all of the cities, the world's oceans, cities don't have oceans, in one place. And we can get a very good overview of sea temperatures at this kind of extent. And then as we start to zoom in, we can actually see more detailed currents in the ocean that are causing the dispersal of these different temperatures. Again, this is all happening in our web browser, in our JavaScript app. Anybody can go and view this on a website. They don't need to install anything, which is one of the really key benefits of using the JavaScript API. It's really pretty, isn't it? Just look at that for a while longer. Okay, so as well as being able to stream in lots of data, performance also helps us out when we're trying to replicate the real world, which is really what GIS has always been trying to do, is create this digital replica of the world that we experience around us. Now, as I say, it's become a little bit of a cliche, but we're going to have a look at weather effects, but particularly why weather effects are applicable to us in the JavaScript API. So here we're looking at a 3D mesh of Utrecht in the Netherlands, and we can apply different weather techniques to it. This is how web scenes used to look, but we can, of course, as we've seen this morning, apply rain and snow, and we can adjust these using sliders. Now, in the out-of-the-box tools like the Scene Viewer in ArcGIS Online, this is a static thing that you set at the time you author your scene, and you can tweak it between bookmarks and do some things like that, but essentially it's kind of static. When we're working with JavaScript, we can have different information powering these weather effects. So a little project we've been working on in my team recently is to have a browser window that opens, gets your geolocation, grabs the highest quality data from the Living Atlas, and then goes up to a weather API to figure out what's the time of day in your local area, what's the weather, and really build like an immersive experience of your local area. And that can be the basis for all sorts of other functionality that you pull in. So when we use this in JavaScript, we can do things like that, grab a weather API and actually replicate the real world. And one other cool thing about this, just to show you before we move on, is another kind of real world phenomenon that we can model is flooding. And the rendering of all of these different effects is getting really impressive with each release. So now we have this animated water, hopefully you can see that on the screen, that's rippling away. It's also reflecting the 3D mesh, and it will reflect things like clouds in the sky as well. So, I mean, who would have guessed a few years ago that GIS could look that true to life? It's really, really cool. Now, having this kind of fidelity of information is also important for performing 3D analysis, as well as just visually making immersive experiences. So here we have a shadow analysis. And once again, because we're using this in JavaScript, we have a lot of control over what exactly we want to visualize here. So this could be great if you have a proposed urban development and you want to understand the impact it's going to have on light on surrounding buildings that are already there. So we can change time of day, time of year to define where the sun's going to be in the sky. And then we can drag like how many hours of the day do we need light to be reaching these buildings. And then finally we can select different scenarios to see how they'll be affected. But something I wanted you to just take note of here is the detail we have on these buildings. Let's see if I can just zoom in a little bit. Because we've got that performance to stream in these really high quality buildings, the actual analysis is improved because we can have these things like balconies. And as you mouse over this, look at the performance we get in understanding the exact amount of daylight you have on each surface of this building. So just a whole lot of detail there that wouldn't be possible if we didn't have this really good performance. One more note on performance and ability to have a lot of data before we move on to a different category is this elevation widget. This is taking into account not just the terrain, which we've traditionally been able to do for a long time, but also buildings. So as we draw this out, you can see we have the orange section here is showing you the terrain at a really detailed level, and then we have the kind of purple color has the buildings. And again, to get actual kind of quantifying this with numbers, we can just mouse over. And again, the experience is just so nice because the performance is there. So we're going to move on from performance, although it underpins everything, to talk about some cartographic techniques now. So as well as replicating the real world, we can use these techniques to communicate information in kind of creative ways. Here we have world population count that's being displayed by extruding polygons. And it's a really powerful way to actually visualize this data. And you can really clearly see the areas of the globe that have very dense population, and then the huge swathes of the globe that are largely unpopulated. Once again, I don't want to labor on the point, but we can get actual numbers on this information just by mousing over. And once again, performance is really cool. Additionally, another cartographic technique, this time charting. So we've been able to do charting for a while as a kind of or kind of aside your map. You can have a chart, a bar chart, or a pie chart, whatever you want, and represent data that way. But now with the latest release, we can use that as actual symbology of data on the map. So we've got pie charts here showing the breakdown of different information, but also in a multivariate way, so we can adjust the size of them. And we can essentially do this across a whole country, which gives you a really creative way of understanding the data. But once again, zoom into them. And because if we have real-time services coming into our app, all of these pie charts can be updating on the fly as well, giving you an understanding over time. Blending modes are also something that's become really popular, and they've made their way to 3D now as well. So let's think about a scenario where I want to create a hiking map. So here we have a mountainous area, and I've brought in OpenStreetMap because it gives me really useful information about the terrain, about walking routes, about the elevation of different peaks that I'm wanting to get to. But what I also want to see is more detail on the terrain. So I might want to bring in something like a hillshade, because whilst this surface model is really detailed, by bringing in the hillshade, it gives us that impression that there's even more detail in there, and we can start to pick out ridges that we might use for walking along. But how would I display both of these together? Well, I could reduce the transparency of the base map to expose the hillshade, but that might look a little bit washed out and not quite what I'm looking for. So instead, we can use the new blend modes in 3D to bring both of these data sets together. So this way we can clearly see the different terrain and the hillshade underneath each other. There's lots of different blending modes that you can experiment with depending on what your data is, the kind of how bold the colors are and how you want them to interact. And it's really as easy as just changing the variable on the blending mode, and you'll be able to cycle through all those different really nice ways of blending these two data sets together. One more cartographic technique before we move on to our final category. I really love this one. So these are new media layers. So with media layers, we can embed either images or videos onto our maps and scenes. Essentially how we do that, we take our image or our video, we define the extent that we want, the bounding box, and exactly where we want the corners to be, and it will then map it onto your scene. So in a way, we're bringing kind of a simplistic version of georeferencing into the web browser, which is really powerful. In this particular example, we've got a video from NASA, which is looking at the sea salt, smoke, and dust. And honestly, this is just fascinating. I mean, we all know that the atmosphere essentially acts as a fluid, but it's really hard to appreciate it until you see it in something like this. The way that we've got dust coming off the deserts, interacting with all these different, what's the fancy word for it? I'm going to say things, different things in the atmosphere. But at the same time, this is just a video, so it's pretty lightweight and easy to bring into your app. And as I say, you can do that with static images as well. So the final thing I wanted to talk about is the variety of data that we're able to represent in JavaScript now. And to do that, we're going to take like a trip through the Earth, starting underneath the surface with this 3D scene of major earthquakes in 2019. So with this, we're able to strip away the base map and the terrain and actually look under the surface of the Earth. By doing this, it's a really intuitive way of seeing kind of the epicenter of earthquake events, how strong they are, how deep underground they started. And another thing about using the JavaScript API is the amount of control that you have over the visuals. So hopefully you've noticed throughout these examples, they just look really nice, they're really engaging, and that's a really powerful way to communicate geospatial information to any audience, is by just having that control over the way you display it. So we can go underground. We can also go underground with things like utilities, as you saw briefly in Glasgow's example this morning. But subsurface is becoming a really big part of the API. And then bringing ourselves back up to the surface, but this time having a look at inside a building, so indoor GIS is an area that's increasing all the time. So we can interact with this. This is the main train station in Zurich. So we can start off with the context of the city around us and seeing the building, and then we can strip away different layers of information and start to look inside the building at the different spaces, what they're used for. And again, kind of drilling down. So having floor-aware maps in your apps is increasingly very useful once you start to move to the indoor GIS space. And then potentially in the future bringing things like indoor positioning into the apps as well. So we've gone underground, we've gone back to the surface. Let's finish off by looking way up above the Earth. This is a Satellite Explorer app built with our JavaScript API. I loaded this up the other day and honestly was kind of surprised how many satellites we have flying around the Earth, and also how far away from the Earth some of them travel. So with this app, we can select the path of different satellites. Yeah, these are the kind of ones. Look at that. Did you know satellites went that high? No? Okay. But we've also got, of course, a tremendous amount of satellites hugging the Earth in various different orbits. And with this, we can explore the different paths, as I say. We can even go to the satellite itself, to its current location. There we go. And visualize how far above the Earth it's flying at the minute. So hopefully through those three examples, you can see just the variety of data that we can consume wherever it is in relation to the planet. Okay, so let's jump back to the slides. So I wanted to leave you with some resources. It's definitely, in the past, it's been a little bit tricky to stay up to date with some of this stuff, but nowadays we're publishing really good quality information for you to stay up to date with. The first place I would encourage you to go is the ArcGIS blogs. So on here, you can filter by different products and different categories that you're interested in. You can also, of course, just look at everything and get an update across the board in ArcGIS. But here we've filtered it to JavaScript, and we get information about latest releases and the functionality that's coming. We also have more kind of interactive demos where people have been much more clever than I can to build these really cool demos. There are a series of GeoDev webinars and events, which I would encourage you to check out. These are free to attend. They run online for the most part, and you can see the next one coming up is about our map game engine SDKs. So, by the way, all the links for these will be in the slides that we'll share after, so don't worry if you're not taking notes. There's also a GeoDev YouTube channel, which has some really good videos, kind of how-to style, also some events and kind of longer form pieces to give you a deep dive into the technology. Definitely recommend checking that out. And then the final one, JavaScript specific. Did you know that on GitHub you can access the next version of the JavaScript API? This is great for a lot of reasons. It's great if you need to test the next version against a build of your app to see if there's any breaking changes that you need to address. It's also really good because there's a change log on here that you can have a look at some of the features that are coming in the next release. One thing I would say, this is definitely a kind of development channel, and not everything you see in here is guaranteed to be in the next release. However, it will give you a really good idea of the kind of features that are coming down the line and actually enable you to get hands-on with them and feedback to the development team around kind of ideas and how it impacts the different apps that you're writing. And that was everything that I wanted to show you this morning. I hope that's given you a good overview of some of the latest features. Hopefully you've been inspired with some ideas that you can implement them with. And once again, thinking in the context that lots of these features make their way into the out-of-the-box software. So if you're not a developer, you're just using ArcGIS, then again, I hope that's given you a good glimpse into what we have.